Good morning. Today, you guys are going to transition from transformations into congruent triangles. So we're gonna still do a little bit with transformations, but really start focusing on congruent triangles. So let's take a look at our triangle here. It says, describe a transformation that can be performed on A, B, C that will result in a triangle being created in quadrant one. So how can we transform this triangle to get it in quadrant one? So I'm gonna use some patty paper and we'll take a look. So we can do a couple different things. We can obviously translate it, which means slide it up. We could also rotate it like this. We could even do a series of things, rotate and translate if you wanted to get fancy. But go ahead and choose one way to get that triangle into the quadrant one and record your transformed triangle in quadrant one. It does not need to be the same as mine. I'm just going to be boring, so while you're transforming your triangle, I'm transforming mine also. I'm choosing just to do a straight translation up. I think that will be the easiest when I'm trying to explain this to you, so that's what I'm going to do. So your triangle might not look like mine. You might have rotated it instead. You might have translated it a different amount, and that's okay. Okay. So for part A, we can say translate vertically. Okay, or we could rotate counterclockwise 90 degrees. So those are some options. Well, the transformation you described preserve the size and shape of the triangle. Explain your reasoning. Both of these transformations would preserve the size and shape, and we know that because I used patty paper, and when I brought it up, exactly the same. If I rotate it, exactly the same. Okay. Yes, and then explain your reasoning. We can describe that we used patty paper to move the figure and keep it exactly the same. And really all rigid transformations like the rotate, reflect, translate, transformations do preserve the size and shape. The only transformations that do not are dilations. So we wouldn't want to dilate this figure if we want it to stay the same size and shape, okay? Okay, so I already performed the transformation, and I imagine you did too. So we're gonna name it, instead of naming it A1, B1, C1, we're gonna name it D, E, F. List the coordinates of the new vertices of both triangles. List the coordinates of the vertices of both triangles. Okay, so we'll do our original. So A is 1, -8. B is 5, -4. C is 8, -9. D is 1, 2. E is 5, 6. F is 8, 1. Okay, so I purposely named the points next to the corresponding point, okay? So A and D would be considered corresponding because they're the same part of the triangle, just slit up. B and E are corresponding, C and F are corresponding. If you had rotated that triangle, you would need to make sure that, for example, if I had rotated this triangle, then I would need to make sure that I knew that this point, or this point vertex of the triangle corresponds with this vertex of the triangle because it's turned, okay? All right, so we're gonna write a congruent statement now, and I actually taught you guys how to do this last year, so you should be really good. But I'm gonna go over it again with you. Okay, so when we're writing the name of a triangle, we have a little triangle, and then we write the name A, B, C, okay, because these are the points. And then we have our congruent symbol. Now, when we're saying that this triangle is congruent to this triangle, we want the points that are corresponding with each other to be in the same order. Okay, so we don't want to say triangle ABC is congruent to triangle FDE because F and A don't correspond with each other. Okay, so since A and D correspond with each other, we want them to be first because the A was first in the other one. And then B and E are corresponding, so we want them to be in the same position in the name. And then C and F. Okay, so A corresponds to A corresponds to D, B and E are corresponding, and C and F are corresponding. Okay. Now, once you've written a correct congruent statement for the triangles, a lot of our work is done for us. We don't even need to see what we did above, okay? I hope I got most of that in there. Let's see. I don't know if you were able to see that when I was down like this, but okay. Most of our work is done for us because we wrote it the right way. We know that angle A and angle D are congruent, angle B and angle E are congruent, and angle C and angle F are congruent, okay? So using your statement, identify congruent angles. So we're going to say that angle A is congruent to angle D, which you can see in the picture above. Angle B is congruent to angle E, and angle C is congruent to angle F. Okay? They're already in order. We already knew which angles were congruent to each other. Now we're going to write our congruent sides. And again, because of the way we wrote our triangle, okay, we know that line segment AB is going to be corresponding to line segment DE because of the order, okay? So line segment AB is congruent to line segment DE. And you can look back at your picture too, just to verify that you are writing the correct thing down. And then triangle, or excuse me, side BC, so line segment BC is congruent to EF. And then this is, well, not super tricky, but then you're going to be doing line segment DF and AB, okay? And if we look at our thing here, DF and AC are the last line segments, because we already said that AB and DE were congruent, EF and BC, so we have DF and AC, okay? All right. So the whole purpose of today's lesson is just to get you to start understanding congruent triangles and being able to write congruent statements for the triangles, the angles, and the sides of the triangle. Okay, so let's go ahead and flip over and get some more practice. Okay. Describe a transformation that can be performed on MNO that will result in a triangle being created in quadrant 3. This is exactly the same as the other side, okay? So what I want you to do is I want you to go ahead and see if you can do all of this just like we did on the other side. And I'm going to do it as well and take a picture of it and post it after the lesson. So you can try this, use your class time to do this side of the page, and then you can take a look at mine and see how it went for you, okay? I do have one quick thing before I end the video today. On your homework tonight is pages, I believe it's pages 16 and 17. Yes, okay. So on page 16, it says draw and label a pair of congruent triangles with congruent statements for the triangles. Okay, now you're not going to be doing anything fancy. There's not even graph paper here. Your triangles can be whatever you want them to be as long as they kind of look the same. And you're assuming that they are. Okay, so maybe your triangles look like this. Okay, so I don't want you to get hung up on that first part of the problem where it's asking you to draw a congruent triangle, because it's just, it's all they're asking you to do is this. And then you'll write a congruent statement for it. Okay, so your triangles can look however you want them to look. Okay, and then you're going to go through and you're going to do the things that we did in class. And then here you have two triangles. One is transformed down below, and it's all, they've listed out everything that's congruent, all the congruent sides, all the congruent angles, and then they are stating that the two triangles are congruent. This is the one type of rigid transformation I didn't show you yet. That's a reflection, but that also creates congruent triangles, okay? And then this example right here is showing you what to do on the back side. On the back side, you have a transformation happening. You're gonna label all of the congruent angles, all the congruent sides, and then a congruent statement for the triangles, making sure that all the corresponding angles are in the right order when you're doing your congruent statements, all right? Please email me if you have any questions. smcdiarmid@rcsd.k8.org, or you can visit me in EX1. I do not believe that Mrs. Taylor is going to be coming back. Mrs. M will be back at the end of April, early May. So in the meantime, you can come see me anytime you have any questions or if you need anything. Have a great day, you guys.